Hey guys, so today we got this dense looking function. It looks pretty complicated, especially when we start thinking about taking the derivative of this thing. That's okay, we'll get through it. This function in particular is gonna run us through a few different type of rules. The first I can see is power rule, and then we're gonna have a quotient rule. And we're just going to take and a chain rule, and we're just going to take this step by step, as you should with really any derivative. I know sometimes we get a little anxious when we see these things, but I think the most important thing is that we take it step by step. So let's start. Let's start with telling ourselves that we're going to take the derivative of this. So I'm going to say take the derivative of this. Okay, so what we're going to have is we're going to have t prime, that I'll probably start leaving out. This t prime is going to be equal to power rule, so I'm going to drop this 4. Going to keep what's on the inside. And I went over this with, especially when we went over the radicals, with this chain rule, and when we have this power up here. And so that's going to drop the power of this to 3. And now what we're going to be left with is the chain rule. And that's going to be taking the derivative, again, everything that we have on the inside. That's it. We don't carry any powers. We don't carry, unless they were inside, we don't carry any powers or anything like this. If it's not raised to the power or something, then we kind of leave those alone. So let's do this. So let's write it. So I'm going to be taking the derivative of this 4. And that's it. And we're going to take the derivative of this. Okay, so now this is what I want to work on. I want to work on this derivative. I want to kind of say that everything here is good. And we're going to start taking the derivative of what we have on the inside. And it turns out this is, just looking at it, this we're going to call for a quotient rule. So let's get to that. So from the last video that I did, I kind of want to reiterate that we always want to use this roadmap, because the quotient rule could be a lot if you're just trying to think about it and then put it all down on paper. So let's start. And what I mean by roadmap is that we have this f over g prime squared down on bottom. Cool. And so in this case, this is going to be our f, this is going to be our g. So again, what I want to do is I kind of just want to set this up because we're going to build on something here. These are kind of those notes that we're going to kind of have off to the side. And we'll bring everything together at the end. But for now, I just want to work with this multiplication and what we have in here for this quotient rule. All right, so f is going to be equal to 4 minus 2x. And now the derivative of this is, since 4 is a constant, it goes away. We're going to keep that negative, and we're going to be left with 2. And then what we're going to have on this side for our g was what? 3x minus 1. Okay, so at least these are pretty decent. Sometimes quotient rule, these could be a little nasty. In this case, it's going to be 3. Okay, this looks good to me. again, that it doesn't matter if it's a negative or positive, it's going to drop out like the 1. It's going to go to 0. Okay, so let's start piecing these together. So we're going to have f prime negative 2 times g, which is 3x minus 1, minus, and now I'm going to open another parentheses. I do this so we don't get confused, right? Because now we're going to have 3, and then f is 4 minus 2x. Okay. This is all over 3x minus 1 squared. It's that g squared. Okay. And so this is all kind of, let's remember, because this is still part of multiplication with things on with what we solved for earlier on the left side. But let's continue to focus on this. So what I'm going to do from the last one, I'm going to just distribute this 2 to that, and to that negative 1. What I'm going to do is I'm going to distribute this 3, not negative 3, just this 3 to both of these. And then I'll distribute that negative in a second. For now, I just kind of want to focus on this. All right, so I don't want to take too many steps. All right, so, well, too many steps at once is what I mean. All right, so for here, we're going to get negative 6x, right? Negative times, the negative is going to be a positive, so that's going to be plus 2. Now I'm going to have this negative, and now I'm going to open it up because I'm going to have parentheses. I'm going to have 3 times 4 is going to be our 12, and then minus 6x. Okay. And then we'll be able to, now if you can see, we're going to be able to simplify, and we want to simplify. We're always trying to look to simplify, especially in calculus. Okay. So now what I'm going to do is I'm going to take this negative and I'm going to distribute it to these two factors, to these two terms. What we're going to be left with is I'm going to keep negative 6x plus 2 minus 12 plus 6x. That was nice how that kind of worked out. And now this is going to be 3x minus 1. Okay, since we have, if we can see, we have this negative 6x and this positive 6x. Well, these are both going to cancel out to 0. What we're going to be left with is this 2 minus 12, so it's going to give us negative 10. Okay, so we're going to have negative 10 over this. Again, if we could imagine, we are going to be multiplying this by whatever we have on this side. Oh, looking good. Okay, so this one wasn't too bad. Of a quotient. I think the most important part, I think sometimes what we can do in these circumstances when we have all this chain rule and stuff is not take things step by step. And when we do that, we could lose some lose values when we're doing our math. So let's remember that this is all going to be multiplied, right? If we go back to top, because this was just the derivative of this term here, of all this 4x minus 2, right? That's just this derivative. So if we go back, we can see that we still have all this stuff, and it's going to look like if we really wanted to simplify it, we'll be able to simplify it pretty well. So I'm going to take all this stuff, I'm going to copy. And paste this in here. All right. I don't think and then that's going to be equal to t prime. Okay. So what I'm going to do here, it might seem a little weird at first, because we can simplify this. I think At this point, it's pretty good, but we want to get like really good, right? Um, so this is, and remember, this is like a continuation, and it just kind of continues to go. I'm just kind of dragging it along. We've always had this term being multiplied, just so we know where that's coming from. And so it's still being multiplied to this derivative. And what I'm going to do, see this, so we got this -10. Well, we got this 4 over here, so we can multiply those. And then what I'm going to do is I'm going to take this 3, and I'm going to separate them, because if we had something like this, a over b to the 4th, it's like same thing as saying a to the 4th over b to the 4th. Okay, so that's what I'm going to do. I'm going to kind of do that with this 3, and I think you'll see why in a second. So I'm going to say it's equal to -40, right? And this is all 4 is 2x. See how I'm kind of separating it. I'm multiplying this -10 to this 4, giving me that -40. Still, since all this is, there's a multiplication here. So this 4, it's like 3 terms being multiplied. These 3, this 4, and then these 2 kind of big blocky things being multiplied by each other. And I'm going to keep that 3 up there. Now what we're going to have down in the bottom to the 3rd, 3x minus 1 to this. Okay, now this is what I was saying. So when we have something like this, right, like if we had a squared times an a cubed, what we have is an a2 plus 3, right? Because since these bases are the same, we're able to add the exponents and then get a to the 5th. So I know it may not be as obvious like at first, but this 3x minus 1 is the same base as this 3x minus 1. So I'm going to combine those powers. So if I had -40, nothing changes on top, or minus 2x. And this is kind of just going really, making sure that we really simplify, make everything look real good at the end. Right. Oh yeah, that looks clean. Now that's an answer that I'd like to present to somebody, because look at this. We could have kept it like this, but that looks nasty, and this looks, almost just as nasty, especially with these 2 terms in here. I mean, this is still correct, but we want to simplify all the way down. This is going to be equal to a t prime. So again, we want to take these step by step. So the first step when we did this was to write ourselves out this. All right, let's remind ourselves we're taking this derivative of this thing. And what that gave us was a power rule. So we said drop the power, right? So when we drop the power up top, we drop the power, drop the number from here, from a 4 to a 3, right? -1, power rule. And we took what was in the inside, these parentheses, and we did the derivative of that. And it just so happened to be that what we had inside of here was a rational looking function. And when we did that, we had to get quotient rule. We had one thing divided by another. You're always going to want to do quotient rule. And you're going to always want to do it if there's not a, if it's, if we have like an x down below, right? Because if we had, I don't know, 4 minus 2x over 2, then we would, divide everything by 2 and then work from there, kind of get those constants. But since we have this x down and bottom, we're going to want to we're going to want to take the quotient rule. And that starts by taking this, doing our map, kind of working through it step by step. Distributing, this is doing the algebra, right? Like I could have stopped here and said, well, that's it. I could have had this and this, but we're in calculus, so we really want to be able to simplify, because look, it simplifies out really nice. We get rid of the x's on the top. All right, look at that. Oof. Let me double check. Yeah. it's going to be plus, yeah. Nice. Yeah, okay, so that worked out really nice for us. Okay, and then got that -10, and I think this is probably the most tricky part with the algebra. Understanding that I can take this 10, multiply it to this 4, get that -40, and then separate this out and be able to get something that looks really clean in the end. So hopefully this was a little bit of help. I know it's a longer video, I think, because there's a little bit more moving parts, but take it step by step and know that we're multiplying everything over and over again. I think something that could be common if when you're working through this and you start getting focused on this quotient rule, you could get to the bottom and think that's it. No. Don't forget that you had something that we started off with too. So just be careful, take it step by step, and then work it out. Yeah, it's a fun problem. So hopefully you guys find it fun too, and good luck. All right, see you guys.